Hey, so welcome back, and this is another daily code problem. So today it's called Solving Questions with Brainpower, and it's a medium level dynamic programming problem. And basically you're given a two-dimensional array here where each index is a particular question, and you want to see what is the maximum number of points that you can earn by passing these questions. But the catch here is that each question has a particular number of points. So question at index 0 here will give you 3 points if you solve it. But they come at the trade-off of, okay, if I answer this question, it comes at a cost of 2. And the cost of 2 is a bit confusing. It's explained at like this part here, Brainpower at I. And all it means is if I want to grab this number of points at this question, I then have to skip the following 2 questions. And so then I can't do these 2 questions, and I have to skip all the way to the last question here. We're saying in this case, I could grab 4 points, but then I have to skip the next 3 questions. So I'd reach the very end here. Okay, and so to do this, it's actually a dynamic programming problem where you can do this like top down and bottom up, where basically you have two different decisions that you can make at each step. You start at like index 0 with a total like number of 0 points. So let's say 0 points at index 0. So let's say like maybe just for the sake of simplicity, this will be like a $sign, and then this is the index. And so 2 paths you can go down are, okay, I can either add this number of points and skip to 2 places forward, or I can just go to the next question. And that would represent, okay, what if I want to add these 3 points, but now I'm at index 1, 2, and then you jump an extra time because you're also skipping this one, so you get to the last index. So now I'm at index 0, 1, 2, 3. Or I could just skip to the next one so I don't add anything, but then I am now at index 1. Okay, and you just keep building this recursive tree, and eventually you find the maximum. But there is actually some memoization that you can do here. I hope it can be fairly natural, where you can assume that, say this chain was very long and you had a lot of questions you could solve, there's probably multiple paths that will lead you to like the same question here. And so that's a lot of repeated work. And so you want to be able to cache that whenever you can. And by doing that, you're going to have a time complexity of O of n, and then a space complexity also of O of n. And that's because you're never going to get to and have to evaluate a particular question more than once. So you just visit each question at most once, and you have to store it, so that's also O of n space complexity. Okay, so to do the top-down solution, I'll start with that, and then I'll show you how to do the iterative like bottom-up solution, which is usually preferred, but you don't actually get, in this case, any optimizations out of it. It's just, I think most people prefer a true dynamic programming solution, which is bottom-up. So what you're going to want to do is return the result of a depth-first search function, which will take in the current question as a parameter, or the index of that question, and we just want to return the result of this recursive function starting at index 0. So we evaluate the first question. And so we also want to be using memoization, so we're also going to use a hash map. You can also use an array, but I find this more intuitive. And so the base case here is that, okay, if our index I is greater than or equal to the length of the number of questions that we have, then let's just return 0. And this just represents like the number of points we have at that point. Like you don't get any extra points for reaching the end, and so you just want to return 0. Otherwise, the other kind of simple base case that we can evaluate is if our index is in our hash map. So has this question already been solved before? And if so, let's just return that pre-computed solution. Okay, and so from here, we want to go down our 2 different paths and take the maximum of it. And so we just say, okay, the maximum at this particular index, and we want to store it in our hash map for memoization, and I'll just put that here. This is memoization in action, is the maximum of these two different paths we can go down, and we're just going to want to return the result of this. And so the first path that we can go down is, okay, starting from here, we can either use this number or we can skip it. And so if we want to use it, then we say, okay, let's add that number of points to a running sum, which we can get by points comma cost is equal to whatever is in this particular question that we're on. And then we say, okay, but then we want to call a recursive function here at this particular index plus the cost. So we skip that number of places forward, and then +1. And I think I explained why we add that earlier. And so that's the first path. The second case is, okay, what if we don't add this number of points and instead we just move one question forward? And all that is okay, we just say depth first search at the index I +1, right? So we're not adding the points at this question, we're just moving one step forward. Okay, so let's go ahead and try that. Looks good. And success. So that's the top-down memoization approach. Now I'm going to show you the bottom-up iterative solution. You don't have to do it this way, so if you want to stop here, totally okay, but I think it's a great practice question. And so, yeah, so from here, what we're going to want to do is define a DP array, and we just fill it all with 0. And we take the length of this questions, and we're probably going to use it a lot, so let's just store it in a variable. And so for this one, you want to return DP at index 0. And it might not feel very intuitive if you're new to DP questions, why you want to return like the first index and not like the last index. But if you remember our memoization approach, our recursive solution, that answer was kind of propagating up all the way to like the first index again. And we were returning depth first search like at index 0. And so we kind of went all the way down the recursive tree, hit that base case at returning 0 and propagated that answer up. And so we're mimicking that relationship just more explicitly using a for loop. So we're actually going to iterate backwards. So in the range of n minus -1 is where we'll start. So we're starting at the end of this array, like as if we hit our base case. And then we just want to keep going until we hit the very beginning. Okay, and so from here, we're going to first want to get our number of points and our costs like we did earlier. And we're going to want to take the maximum of those two different paths. So DP at this particular index is equal to the maximum of our two paths here. So the first one is, okay, what if we just skip it? Let's just do the simple one. And that would just be, okay, let's say it's DP at I +1, since we're going backwards. Say we're at this index, we want to just grab the answer what we had previously, since we're just propagating that answer up and we're not like adding anything to it. So let's just add what we already have here. And we want to add this, and we have to be careful of our bounds here. Only if I is less than n. Less than n minus 1. Yeah, okay. And now we'll just make sure that we don't go out of bounds out of our array. And then otherwise, we just want to return 0. Okay, and so that's the simple case. The second case is, okay, what if we want to actually add these points? And that's going to be, okay, we want to include these points plus, and this is kind of the trick here, I +1 again, but plus the cost. And what that's going to mimic is, okay, say we're at this one, and we grab these points, we're at 2, And then we could say, okay, +5, but there's nothing there, so we don't add anything. So now we're at 2 here. And say we evaluate these conditions, but when we're at this point, we want to say, okay, let's add 3 to what we pre-computed 2 steps ago. And so we just skip these 2 and add whatever is stored in our DP array at this particular index, which is done here. Okay, so we want to do this if our index plus the cost plus 1 is less than n, I believe. Yeah. Otherwise, we just want to add the number of points, and that's this case where, okay, when we do +5 here, there's nothing here, so let's just add 2 instead of adding whatever is 5 steps behind us, or ahead of us, really. And yeah, so I think that's the solution. Looks good, and I think it's successful. Yeah, success. So yeah, that's today's daily LeetCode problem. Thanks for watching. I hope it helped a lot. So this was the kind of bottom-up solution. Totally recommend, starting with memoization, starting with recursion, defining that recursive relationship, then seeing how can I use a hash map or an array, some dynamic lookup table, so that you can pre-compute, or you can look up pre-computed work. So you do that, so you can minimize that time complexity with a trade-off of space complexity, and then look at, okay, if you're able to solve that, then how can I, translate this into a bottom-up approach? And then from there, sometimes you get a 2-dimensional array, and you want to say, okay, how can I take this 2-dimensional array and see if I can make a 1-dimensional array? And that's how you can really save sometimes on the space complexity. But yeah, hope that helped, and good luck with the rest of your algorithms. Thanks for watching.